Hello everyone. Today I am going to talk about Routing Information Protocol, RIP. RIP is a industry standard protocol, means it is a non-Cisco proprietary protocol. It is a simple to configure and manage the small networks protocol, which we usually use in a small lab setups and in a small environment. RIP uses the hop count as a metric. So whenever the 15 whenever the multiple routers are connected to each other, so RIP uses the hop count to uh, share the data to the next router. So basically RIP does not maintain or calculate any kind of cost, or does not consider bandwidth or quality of links. It does only consider the maximum router connected. Like it does only consider his directly connected link or on a router. So hop is basically the hop is basically the distance from one router to the next router. So RIP only calculates the number of hop counts and the shortest route exists to reach to a destination as per the routers connected. So he takes the route. So one of the limitation of RIP is that it only supports maximum 15 routers in its network. So if we so it is clearly states that it does not support it is not important to it is not important for the large networks where we need more than 16 routers. So you have to always use the maximum 15 routers. RIP does not basically if you will add one or more router in the network while running the RIP, the router will be on the unreachable state. So that's how RIP bug. And RIP has two versions, basically three versions. RIP has three versions: RIP version 1, RIP version 2, and RIP version next generation. RIP version is a classful routing protocol, means it works on only the classful addresses, and it does not support VLSM or CIDR. And we do not prefer to use RIP version 1. Instead of, we use RIP version 2. It is supports classless routing. It is a classless routing protocol. It supports the subnetting as well. It sends the multicast messages on the address of 224.0.0.9. So now question comes, what is multicast? Multicast address, it is a range specified in the class D, which is reserved for multicast. So it is a class range. So multicast is basically where multiple objects are connected to a singular group, means everything whatever the messages you are going to send on multicast address, so it is going to use that particular address for it, and RIP will send it. So means in routing protocols you see that there are multicast address, so it uses those multicast address to reach to that destination. So it is a overall idea of RIP and the multicast, and that's enough to know about RIP. And the RIP has the faster convergence. If it is 30 seconds, it's hello timer. So whenever the RIP has to know the routing information of the connected routers. So if it's directly connected routers only, so he updates his routing information routing table into the router like after every 30 seconds. So it is very delay time for router, and while working in the RIP. So overall RIP is not suitable for larger environments, but when we are using it for basic functions and stability, where we do not need to where the aim is not to scale the network or make it very big network to work, it is very useful for small home networks and lab environments. So at that if we look at that perspective, RIP is good, but as it has its own limitations, like not having faster convergence time, or supporting only 15 routers in the network. So that is all about RIP, and it is a basic introduction that I have given it to you about RIP. Thank you. If you have learned something, please do like my work and go ahead. Thank you.